So one of the things that I want to talk about are the key factors involved in maintenance strategies. And this is an interesting topic in itself. We have in the United States in particular a lot of different strategies associated with maintenance. Some of them are run to failure and do nothing until it breaks. And that seems to be a real popular and costly approach to our environments. And yet I see it going on in organizations constantly. So we have technology today that can monitor equipment, and sensor objects can be put in place to tell us when it's running well and when it's not. We can put sensors on it to monitor temperature and vibration and things like that, and yet we ignore them in a lot of cases and just continue to run to failure. When we talk about the cost of equipment failure, it's an interesting situation because people don't seem to understand that it's the cost of the operator standing around, it's the cost of lost production time, it's the cost of fixing the equipment on an emergency basis, which is always more expensive than if we could have prevented that in the first place. Corporate cultures play a huge role in maintenance strategies. If you have a plant manager, as an example, that doesn't give the piece of equipment to maintenance on a regular basis for preventive maintenance, scheduled maintenance based on a time frame, you end up with the run to failure mode. If you have a situation where preventive maintenance records aren't kept, and so you don't know the time frame between the last maintenance and the next maintenance, and you have no information on how maintenance is performed or who did it, again, you run into a situation where the run to failure mode really persists, even though you try to do preventative maintenance. When you get into pieces of equipment that aren't part of production, but things like dock locks and pieces of equipment that could have OSHA implications, it becomes even more critical that you look at your culture and decide how are you going to address maintenance. So I can look at I've seen the bad side in a lot of organizations, and today we're going to talk about how the technology can be applied, how you can change corporate culture to move forward. We want to talk about what's the difference between condition monitoring and true predictive maintenance. Eagle's fortunate to have partners that have both opportunities, okay? We work with Blue Vision, and Blue Vision can give you some AI and condition monitoring, machine learning capabilities. And today, our partner VIE is going to show you what's the difference and how do we get to true predictive maintenance. CMMS becomes a component of that in that, number one, it can trigger work orders based on information, and number two, it keeps the data and history over time of what's really happening in your organization. So the difference is in condition monitoring and true predictive maintenance, and I'll let David speak to this a little bit more later, is drastic. It's truly drastic. So condition monitoring, as we define it, is the continuous monitoring of equipment state and operating parameters. And this is through sensors and monitoring tools. It could be the PLC, it could be a number of things. But what it's really doing is just monitoring the existing state. When we talk about predictive maintenance, we're referring to planning corrective maintenance based on predictions. Now this gets a little scientific and spacey, but David will clear this up for you. Because it's really these predictions that are based on data obtained through condition monitoring and on system-specific knowledge. And that's a huge difference. Some condition monitoring is generic, and you put it on a motor or a gearbox, and regardless of what model it is, what make it is, it just sort of learns what's happening now. We're going to talk about system-specific knowledge, and that's going to be a huge difference in your understanding of the variations of what true predictive maintenance can bring. So preventative maintenance, part of a CMMS schedule and AI machine learning, is paving the way today. The technology allows you to make data-driven decisions and true predictive maintenance decisions, okay? Again, the number of corporations and the rapidity of adaption is something I think David can talk about too as we go forward here. So facilities require a digital platform to capture, store, and analyze the data. This does not have to be in-house. Typically today it's going to be in the cloud, and it's going to be generated by systems and sensors connected by the Internet of Things, or is one of the anomalies or terms that we talk about. Preventative maintenance is key for improving uptime and productivity, and predictive accuracy of equipment failure is essential with the increased demands on price control and things like that within your organizations. Uptime is something everybody talks about, and again, from a culture standpoint, it's something that's being inadequately addressed in many organizations. So the internet is connecting people, data, and intelligent machines while helping to shape the future of equipment reliability. The technology alone without a culture is not going to help your organization. It's still going to take consistency of processes and consistency of information fed into systems in order to get accurate data. So CMMS from Eagle Technology delivers information to the maintenance management team, okay? It helps to put scheduled maintenance in place. It gathers real-time data on breakdown information and reactive maintenance. And it looks, if you look at the data, it helps you improve quality and quantity of the efforts of your maintenance team. The contributions of the Internet of Things to maintenance management are something that need to be explored and implemented, and the processes around those need to be looked at from a global corporate situation. And it's not just I can implement this today and it'll solve all my problems. It's a process, it's a culture change. We need to look at the contributions of IoT to maintenance and include the reduction in costs and efforts, because one of the things that most organizations I deal with are running up against is I can't find a qualified maintenance technician, or they're in such demand that I can never find enough people. I'm always short of people and time to do what I know I need to do. So incorporating predictive maintenance into your system can help focus the use of people into the right areas at the right time to avoid downtime. So I'm going to turn this over to David now.
Well, thank you, Harry and Barbara, and good morning, everyone. It's a pleasure to be here. Again, my name is David Gell, and I'm the head of marketing at VIE Technologies. I'm also nursing the first cold of the season, so with my apologies, I will try to cough my way through this without too many interruptions. So VIE is a rapidly growing company. We're based in San Diego. and we offer a predictive and personalized asset maintenance system for both industrial and facility operators. As Harry did, I'm also going to start off with some definitions. There are many ways to define predictive maintenance, but at VIE we prefer one that brings things down to the practical. So what we like to say is that predictive maintenance and the predictive maintenance system is one that provides the what, the when, and the why of future asset maintenance. In other words, it's a system which can describe what maintenance or repair actions are needed, when those actions are required, and even why the actions are necessary. So, and as Harry mentioned, predictive maintenance, it involves asset monitoring for sure, but it goes well beyond that detection of a potential defect. So condition monitoring, it doesn't answer the questions of the what, the when, and the why. It actually takes an advanced capability to understand the linkage between a symptom, something like increased vibration, and linking that to an underlying early stage defect, say a bearing fault or a shaft misalignment. Even beyond that, additional intelligence is needed to classify that defect and ultimately predict how that defect will cause an asset to degrade over time. So assuming you had a predictive maintenance system operating in your facility, what are the benefits? And Harry went over some of this, and we have a similar view, but maybe a different picture around that. Answering the question really starts out with understanding that a predictive system is an optimization around maintenance. So when it's done properly, a predictive system avoids under maintenance using maybe a reactive or a run to failure approach. It also avoids over maintenance that can result maybe from what's an overly conservative scheduled maintenance approach. So there's actually many benefits of an optimized maintenance system. In working with many different industrial operators, we see it breaking down into three buckets. First, we save on the cost of maintenance and repair. So we see it with VIE deployed solutions and also groups like Department of Energy, research houses like Deloitte. They have found and studied typical savings of 10 to 15%, sometimes reaching 20%. In fact, one of the companies we're working with, they have a $500 million yearly maintenance budget. So 10 to 20% from that number, it certainly gets the attention of the CFO. Second, we improve asset availability and reduce unplanned downtime. So often reducing this by a factor of 2, sometimes 3. So this, in fact, leads to many secondary benefits, including improved quality, scheduling, regulatory compliance, and safety. And the third bucket is enhanced governance. So this is really the virtual paper trail of logging asset operation, condition prognosis, maintenance decisions, and all the actions around those events. All of this is critical for both internal processes and governance and also the regulatory and compliance requirements of many industries. So to understand the capabilities of an advanced maintenance system or predictive maintenance system, it often helps to go back and look at the history, and it's a long one. Many have credited the start of condition-based maintenance to C.H. Waddington and the team that was working to improve aircraft reliability for the Royal Air Force back in World War II. And the team discovered something actually rather incredible. They found that a conservative scheduled maintenance approach, well, not only did it not prevent unplanned failures, but it actually contributed to them. And so as we all somewhat know today, the simple act of opening up a pump has a finite risk of creating a problem. So condition and monitoring was born in World War II, and it's evolved over time, really from the so-called yellow-handled assessment, screwdriver on the motor, to high-precision digital vibration sensors. And we've seen many improvements in our ability to monitor the condition of assets and detect potential defects. But, and here's the key, and what Harry was talking about, making the leap to predictive maintenance is a large step further. Sometimes this has involved human analysts to read and interpret vibration signatures and other sensor readings. And while it's based in science, it also is somewhat of an art, taking into account the nuances and unique characteristics associated with any one specific machine. What's exciting now, today, is that technology has evolved to the point that analyst can virtually be embedded into the system, operating 24/7 and without taking a break. Next slide, please. And so as we look at mechanical systems, that leap to predictive analytics has its basis in the science of rotating machinery. So if you break it all down, most machines really share the same set of components: bearings, races, shafts, gears, couplings, and so on. Vibration science is great at explaining how each of these components will degrade over time and ultimately affect performance. Now, when all of these components are combined into a complex machine, the situation changes a bit. So with tolerances, unique operating conditions, and the environment, each machine has its own unique vibration signature or heartbeat. So assessing the current condition and explaining the what and the when and the why of needed maintenance, that becomes something that's personal to each asset. So in the past, this required human analysts. And as we've mentioned, it's an approach that's time-consuming and expensive. In fact, that approach, the human analyst approach, it's so expensive, really, that predictive maintenance systems have historically only been used on the most expensive and mission-critical assets, something like the turbine generator that you see on this slide. Less expensive assets, like, say, a 30-horsepower motor, that was left to the yellow-handled assessment of a technician. And if you're lucky, there was budget to bring in a vibration specialist once or twice a year. And here's the point here. It misses the mark, right, around operations effectiveness, because as we all know, and as Harry pointed out, it's not the cost of the equipment that matters. It's the cost of the failure. So in many facilities, keeping that 30-horsepower motor running has value well beyond its purchase price. Well, to the benefit of our industry, this is now all changing. Combining new technologies, we can now embed what is essentially a human analyst into a low-cost, battery-powered sensor coupled to a predictive system. So how is this now possible? What's changing here? Well, for one, low-cost precision sensors and high-density batteries are enabling these small and long-life vibration components that can be attached to rotating machinery. Advances in connectivity, that's enabling low-cost wireless connection to difficult-to-reach areas. And then advances in artificial intelligence, cloud processing and storage, these are bringing a means to create intelligent learning to each and every asset in a cost-effective manner. So all told, this is enabling easy-to-deploy and effective predictive solutions. Next slide, please. So let's take a look at an example of how this all comes together in the real world. Among many industries that we work in, VIE has a growing footprint in data center facilities. So in this environment, we can apply predictive maintenance to both power and cooling systems. You probably know that the data center space is known for very high reliability operations. Unfortunately, the maintenance teams have the bills to prove it. So a customer asked us to review the maintenance procedures around a 1 megawatt diesel backup generator. It's a rather expensive asset. The generator, it comes outfitted with a condition monitoring solution, basic wired vibration sensor connected to a local monitoring console. About once a month, our customer would receive an alarm from that system. It was indicating high levels of overall vibration, and it recommended grease be applied to the bearings on either side of a critical coupling. So each time this happened, it was a bit of a small panic. The vendor was called, and they were quickly scheduled dispatched to come on site and grease those bearings. And this was not an inexpensive task. It was costing thousands of dollars each time this occurred. So after a number of these interventions, our customer decided that a second opinion was warranted, was needed. They were not convinced nor were they really shown data that this alarm was caused by a real issue and that this money was being well spent. So our team came in and we installed our sensor and predictive maintenance system. We immediately observed higher than typical levels of vibration, overall vibration. But at the same time, we were also able to show that this behavior was not degrading and was in fact normal for the machine. In other words, our system was able to determine a unique prognosis that was applicable and suitable to this specific asset. This is very much a different result than what was being generated when the condition monitoring system with an overall vibration level was being compared to a simple threshold. So we recommended that the customer actually do nothing for the moment. Fast forward a year, and our system has helped to maintain reliable operation of that generator, and we've saved the customer over $35,000 in unnecessary maintenance. So a real success story for this new approach. So we've seen that the predictive maintenance systems can provide great value. It really is a new and powerful way to think about maintenance and repair. But with anything, there are challenges and best practices to keep in mind when considering the adoption of a solution. So I'd like to go over a few of them. So many solutions that are being marketed today are piecemeal. So you may see smart sensors or analytics packages which are tailored for predictive maintenance. And certainly they will be promoting the same type of benefits as we've been discussing here today. But in the end, this type of approach, it forces you to become the integrator. And that's something that requires both time and expertise to address. Next, many of those same solutions have artificial intelligence engines that are essentially trained pattern recognition systems. So without going into the details and the rocket science, to be effective, these approaches require a huge amount of machine data. And unfortunately, and adding insult to injury, historical data rarely has the quality or what we call the labeling to serve this purpose. So the net effect of this all is that many AI engines require very long pilot programs. They can drag out for 6 or 9 months or more as the system gets trained. So important to try to get around that. Next, wireless connectivity has improved, but not all solutions are equivalent. Getting wireless coverage with some systems may require tapping into the operations network and getting the IT department involved. Other environments, the coverage is simply not possible. Next, cybersecurity. It's clearly it's critical, right, for businesses, and as we know, large and small. No one's immune from the challenges. But getting this right in a predictive maintenance solution, it's still a challenge for some solution providers. And what needs to happen is companies need to bring cybersecurity in from day one in the design. And lastly, and looking at things from a different perspective, and Harry touched on this, it's important to look inward at your own organization. So adopting a new way to manage maintenance and repair comes with many potential benefits, but it may also be challenged by naysayers, by politics, by other forms of resistance. So it's important to consider these challenges at the same time as you review the technological ones. So in order to capture this into something that you can all take away, we've compiled a list of key questions to ask around predictive maintenance and adopting a program and solution. As you can see, we've broken this into 2 buckets. The first is the solution itself. Clearly, selecting the right solution and the company behind it is critical. And so is understanding issues such as the ease of implementation, scalability, and security. And then equally critical is the evaluation of your own organization, whether you and your solutions partner can work well together in this digital transformation. And that's what this really is. Unfortunately, the Industry 4.0 community, they've talked a great deal about pilot projects which die on the vine, right? Stuck in pilot. So it's very important for an organization, really regardless of the size, to come at a project such as a predictive maintenance solution with clear eyes and with alignment on the goals, the people, and the processes that will maximize the chance of success and avoid delay. So as I wrap up, I want to remind everyone why predictive maintenance matters. It's pretty simple: reduce maintenance costs, improve asset availability, and enhance governance. These really are game-changing benefits that are being seen in today's systems. And they're not just suitable for multi-million-dollar assets, but also that 30 horsepower motor that we talked about. And lastly, the adoption of predictive maintenance by an organization requires care, not only in selecting the right solution, but also preparing and aligning the organization. And because of that, well, we recommend that you pick your partners carefully. And with that, I'd like to thank everyone again for joining this webinar, and I'll hand it back to Barbara.
Thank you, David, and thank you, Harry. I'm going to give opportunity now if any of the audience wants to ask any questions. You can use your panel box right now and just type in those questions. And if you have it specifically to somebody, you can direct it to either Harry or David, but feel free to pop in those questions right now and we can see how we can help you. The question is, how can I quantify or justify moving from some activities from preventive maintenance to predictive?
Well, I'll let David take that in a second, but one of the questions that you have to ask when you're asking that question is, what is the cost that you're incurring by not moving to predictive maintenance? What's the competitive disadvantage your company is losing? And again, it goes to culture of an organization, it goes to competitiveness, survivability in today's world. So, David?
Yeah, thanks, Harry. Yeah, that's a great question. So as we travel around and meet with customers for looking to help them get into predictive maintenance, that the question is always one of the first that comes up. And certainly there's going to be a discussion around the qualitative benefits as well as the quantitative benefits. It's generally important when we're trying to quantify the benefit is working with organizations that have at least a basic understanding of the current cost structure around maintenance operations today. In other words, how much are they spending on scheduled maintenance? How much are they spending on unplanned downtime? What does it cost when the factory goes down for an hour or two or three? And that becomes the starting point for a discussion. We actually have some rather sophisticated models that can be used with a customer to say, hey, if we were able to reduce unplanned downtime by a certain factor, how much would you guys be saving? And we can help walk folks through that exercise. So that's a really a great question and something that we deal with quite frequently.
So we have a next question here. Thank you, David. I'm sorry. What percentage of revenue should be spent on preventive maintenance on an annual basis?
Yeah, that's a great question. It sounds like there's a CFO on the line, perhaps. Yeah, I don't think there's a one size fits all. I think it depends in many cases on the industry that you're in. There's certain industries that are fairly high margin, other industries are lower margin. There's also differences around, as I mentioned with the previous question, the cost of unplanned downtime. And so predictive maintenance not only becomes cost savings, it also becomes an insurance policy. So that percentage really varies based upon the application and the industry at hand. So it's hard to give a one size fits all answer.
Before I read the next one, I just want to mention that questions like that, if you are interested in having a review or having a discussion with your company direct or asking one of our presenters today, let's say for Harry, and you want to ask that question, let's schedule a time, just send them an email, I'll send the contact details afterwards, and I'm sure either of them would be happy to sit down with you and have a discussion so that you can look into that a little bit more. I'm going to read the next one now. This one is for you, David. And it is saying, how did you come to that 35K cost savings on the generator?
Right. So we took a look at what was being spent on these interventions that our customer was having to go through. As I mentioned, and you may remember the slide, there was bearings being greased. It was actually specialty grease with specialty technicians that were having to come on site to do that. In general, we reduced the frequency of that exercise by about a factor of 2, actually a little bit more, and that netted out to be $35,000 in savings.
You need domain knowledge to be able to do predictive maintenance. How do your product has it? So I'm presuming it's how does your product do that, or?
Right. I think I get it. That's a very good question. In fact, it's one of the underlying and sort of core philosophies of how we built our technology. Don't want to go into detail on this call, and of course, I'm more than happy to follow up privately afterwards. But in fact, we leverage domain knowledge around vibration and reliability science to augment and accelerate the AI in our system. In other words, baked into our predictive maintenance solution is that domain knowledge. We understand at really an equation level how bearings work, how races degrade, how couplings and shafts misalign, and that actually becomes a core and advantage of how we approach the problem. So it's actually cooked into the technology.
Most of our mission critical assets tend to be utilities, compressors, boilers, chillers, etc. What is the best approach to integrate predictive maintenance for these in factories with aging workforce that perhaps are not ready to receive it?
Well, David, I'll take this first, but I think one of the great things about the predictive maintenance approach with VIE is the fact that it's going to take machine-specific knowledge. It's going to take the science behind the maintenance and help replace ultimately the worker that's not there. It's going to, as David calls it, cook in the answer of what to do at the right time to keep your equipment running. Right, David?
Yeah, that's right, Harry, and I'll add to that. I think the question was about sort of the organizational challenge, aging workforce, and we see that is such a constant theme all around the country. One of the things to remember about this solution is we're not, we say that we're putting an analyst into a sensor, but we're not actually taking away responsibility and capabilities of the maintenance technicians that are on the job, day in and day out. What we're actually trying to do is assist them with a more powerful tool to allow them to do their job better. And it not only helps in poorly or understaffed situations, but as some of these experts retire, and we see this time and time again, some of that knowledge does get baked in, Harry is just saying, into the tech, and so those technicians that are remaining, can do their job even better. So it's very much a complementary solution.
What is better, wired or wireless connect sensors needed for predictive maintenance?
What is better? Well, it depends on how you want to look at it. When the wireless system and environment is set up and established well and properly, and the technology is applied correctly, we feel that wireless is certainly the way to go, right? We look at costs, materials costs, we look at installation costs, we look at the flexibility of moves and changes to where machinery is located. So there's a lot of and there's many benefits of wireless. Now, wireless is not perfect, and there are situations where wireless connectivity may not be reliably established. So there is still some role for wired sensors, I suppose. so we may see that reduce over time as the technology keeps improving. But at this point, we feel strongly that wireless has an overwhelming advantage.
Thank you for taking the time to spend today to learn more about predictive and preventive maintenance and analytic data. Thank you for your questions. I also want to thank Harry and David for the time that you guys took today to come and share your knowledge with us. Right now, you will be able to see the contact details for both David and for Harry. The slide with the video recording will be shared with you afterwards, so feel free to review it again or just copy the contact details directly from there. Thank you, Harry. Thank you again, David, for your time today.
Thank you, Barbara. Thanks, David.
Thank you, Barbara.